Question 3. A certain sport team has its team song performed by a different musician at the beginning of each of its games. The time it takes for the team song to be performed by different musicians can be modeled using a normal distribution with mean mu equals 109 seconds and standard deviation sigma equals 16 seconds. All performances of the team songs are independent. So part A is asking us to find the probability that a randomly selected performance of the team song will take longer than 120 seconds. And you have to show your work. So this part A is pretty straightforward. So first we are going to identify what is the variable here. So the variable right here is the time it takes for the team song to be performed by different musicians. And also it's given that it follows a normal distribution. So to find the probability in part A, we can use normal probability calculation. So we're going to use a bell curve and find the area under the curve to get this probability. So let's write down the steps. Let X be the random variable that represents time taken for the team song performed by different musicians. So it's so important to identify the variable in context. So in this case is the time. And we know that the time can take any value. It could be decimals, it could be whole numbers. So it is a continuous random variable. Just keep that in mind. Next, it is given that X follows a normal distribution with mean 109 and a standard deviation of 16. So the calculation becomes very straightforward. So first we are going to draw a diagram to represent what is it that we are trying to find. So we are finding what is the probability that X is greater than or equal to 120 seconds. So let's have a diagram. It's on the right side. So we are trying to find the area that is shaded on the right side. So we are trying to find the probability that X is greater than or equal to 120. So all that part which is above 120. So shade all the part that is above 120 and find the area. We can use TI-84 to find this, or we can use Desmos, or we can use a z-score table or table C to find this area or the probability. So in this example, I'm going to use Desmos because there is an inbuilt Desmos on your test. So we're going to use this prompt, which is normal distribution, 109/16. So we're going to write the mean and the standard deviation and calculate the probability. So that gives you the probability just like that. So you don't have to memorize anything. But if you're using a z-score table, you have to convert the data value 120 to its corresponding z-score. So here we don't have to do that because we are trying to find it directly using Desmos. All right, so here is how you can do this on Desmos. You're finding the normal probability. So go to normal distribution, just DIST. And in parentheses, you're going to write the mean, which is, in our case, is 109. And then you write the standard deviation, which in our case, it is 16. Now, if you're looking at the standard normal curve, then your mean would be 0 and standard deviation would be 1. But in that case, you should be changing the data value to a z-score. But here we are not changing anything, so we're keeping the time as it is, 120 seconds. So we're going to take the mean as 109 and standard deviation as the 16. And now click on the cumulative probability. We are finding what is the probability that X is greater than or equal to 120. So which is our right tail probability. And now here we have to write what is that data value, which is 120 seconds. So that gives you the probability right here, which is 0.246. So our final answer is 0.246, or the probability that a randomly selected performance of the team song will take longer than 120 seconds is 24.6%. Now part B. 10 performances of the team song will be randomly selected. Let the random variable x represent the number of games at which the performance of the team song takes longer than 120 seconds. Find probability of x greater than or equal to 3 and show your work. So this is the part where one could get stuck. So what is the distribution that we're going to use here to find the probability? Are we going to use the normal distribution or the normal probability calculation or something else? So that is why I mentioned earlier that anytime you're finding a probability, understand what is the variable in context. So in this context, the variable is number of games. Previously, it was the time taken. And also another key information here is all performances of the team songs are independent. So before we do the calculation, let's understand how the variable help you figure out what probability distribution we can use, or what probability calculation we can use to find the probability. Now, if the variable is discrete, the most common distribution for a discrete random variable, at least in AP stats, would be either binomial, geometric, or a discrete uniform distribution. And if it is continuous random variable, the distribution would be a normal distribution. And now we have number of games. Number of games, what type of variable is that? That is a discrete variable. Number of games can only take integer values, either 0, 1, 2, 3, and so on. But at the same time, the previous of the time it takes for the team song to be performed, it can take any value. It could be 120 seconds, 120.3 seconds, 119.5 seconds. So that is a continuous random variable. So since in part B, it's number of games, which is a discrete random variable, so it could be either binomial, geometric, or discrete uniform. So now let's see which one is more appropriate. So let's do our check. If it's binomial, we have to do bins. That means, is it binary? Do they have just two outcomes? Yes, in this case, they have just two outcomes, which is success or a failure. So success would be the performance of the team song takes longer than 120 seconds, and the failure event would be it takes less than 120 seconds. Are they independent? Yes, that is where you use this information. It says all performances of the team songs are independent. Next is, are the number of trials fixed? Yes, it says 10 performances of the team songs will be randomly selected. So they have fixed number of trials. If they don't have fixed number of trials, that is where the geometric distribution would come into the picture. Next, what is the probability of success? Are they all the same? That means, what is the probability that a randomly selected performance team song would take longer than 120 seconds, which we found in part A, that is 0.246. So this is a case of binomial distribution, so we can use binomial probability calculation here. So X follows binomial, with parameters are the number of trials, which is 10, and the probability of success, which is 0.246. So we need to find what is the probability that X is greater than or equal to 3. So we're going to use Desmos. You can use either Desmos or TI-84, or you can use the binomial formula to calculate this. The easiest would be using Desmos. So let's do that. On Desmos, you type in binomial distribution, binom, D-I-S-T, binomial. And then the parameters. The first one is trials, which is 10, and then the success probability, which is 0.246. Close the parentheses and then click on cumulative probability. We are finding probability of x greater than or equal to 3, which is the right side. If it's less than or equal to, that would be the left. And x greater than or equal to 3. So that gives out the probability right here, which is 0.462. So we got the probability of x greater than or equal to 3, which is 0.462. And how do we interpret that? This is not required, but to understand. If 10 performances of the team songs were randomly selected, so I got that part from the context right here, the probability that 3 or more games will have their team songs longer than 120 seconds is 46.2%. Now part C. Ben will attend all of the games for the sports team. Let the random variable y represent the number of games Ben will attend until a performance of the team song takes longer than 120 seconds. Okay, so first things first, identify the variable in context. In this case, it is y, the number of games Ben will attend until a performance of the team songs takes longer than 120 seconds. So here the clue word is until. And again, the variable is number of games, which is a discrete random variable. So the distribution could be either binomial or geometric. Now, which one? So if you look at this, there are no fixed number of trials. It is until the first success occurs. So this is an example of geometric distribution. So y follows a geometric distribution with just one parameter, which is the probability of success, that is 0.246. So how do we calculate the mean of y? If you do not remember the formula, you can go to the formula sheet, the section that says probability and distributions, and if you go down, you can see the geometric distribution. If x has a geometric distribution, the first column says how to calculate the probability, and the second one says how to calculate the mean, and the third one says how to calculate the standard deviation. So first we are going to calculate the mean using this formula, 1 over p. So just plug in all the values, you get 4.07 games. Next, you use the second formula to calculate the standard deviation, which is square root of 1 minus p divided by p. So instead of x subscript, we are using y because our random variable here is y, so which is 3.53 games. Now let's go to part D, where you have to interpret the standard deviation calculated in part C2 in context. So we have to add the context. And now what is the standard deviation? So the standard deviation tells you how the variable in context typically varies from the mean, or the average distance of all data values from the mean. Okay, so if you word it properly, so first we are going to write the random variable in context, which is the number of games Ben will attend until a performance of the team song takes longer than 120 seconds. That typically varies from the mean, and the mean is 4.07 games by about the standard deviation, which is 3.53 games. Now, if you look at the unit of the mean, which is same as the unit of the random variable, the unit which is used to measure the random variable, and the standard deviation also has the same unit.